Hello, friends. After decades of mystery, astronomers have finally revealed the secret companion star orbiting the massive red supergiant Betelgeuse. This elusive companion, nicknamed as Betelbuddy or Siwarha, is a hot young star about 1.5 times the mass of our Sun, rather big, found in an incredibly tight orbit around the Betelgeuse. What are the implications of such a companion? Let's discuss this further. Look up at the winter sky and you will often be greeted by one of the most recognizable constellation, which is Orion, the and also known as Hunter, and shining brilliantly in its shoulder, a beacon of fiery red light is a star that has captivated humanity for millennia, and this is known as the Betelgeuse. But Betelgeuse isn't just any star, it's a red supergiant, a cosmic behemoth so vast that if it replaces our sun, its outer layer would extend past the orbit of Mars, swallowing Mercury, Venus, Earth, and potentially even Jupiter. It's a star living on a borrowed time, destined for a spectacular death in a supernova explosion, and that could rival the full moon in our sky. Yet, for all its prominence and looming fate, Betelgeuse has always been a star shrouded in mystery. Its brightest and famously flickered and faded in unpredictable ways, leaving astronomers scratching their head. Was it dust, internal processes, or something else entirely? Well, prepare yourself because after decades of painstaking observation and intricate detective work, astronomers have finally unveiled Betelgeuse's deepest secret. It has a companion, a dark passenger lurking in its immense shadow, whose influence profoundly shapes this iconic star. And the story of its discovery is as fascinating as the star itself. To truly appreciate this discovery, we need to understand the enigma of Betelgeuse. For centuries, astronomers have noted its unusual behavior. Unlike most stars that follow predictable cycles, Betelgeuse seems to dance to its own beat. Its brightness would swell and recede, sometimes dramatically, sometimes subtly, but always it seemed without a clear pattern. This variability reached a fever pitch in late 2019 and early 2020 when Betelgeuse experienced what became known as the Great Dimming. Its light output dropped by an astonishing 35%, making it noticeably fainter even to the naked eye. The astronomical community went into overdrive. Why this is happening? Was this it? What was the reason for it? Was Betelgeuse finally going into a supernova? The internet certainly thought so. Ultimately, scientists determined that the great dimming was likely caused by a massive ejection of gas and dust from Betelgeuse's surface. A colossal bubble of material propelled outwards, cooled and condensed, forming a temporary opaque dust cloud that partially obscured our view of the star. It was dramatic event, but it didn't even fully explain the star's regular long-term variability. Even before the Great Dimming, scientists knew there was more to Betelgeuse's story. Theoretical models and the red supergiants couldn't quite account for all its quirks, particularly its well documented, though sometimes erratic, 6 years brightness cycle. It was a puzzle piece that just didn't fit. So why suspect a companion star? Why do not suspect a companion star? Well, in the vastness of space, single stars like our sun are actually quite rare. The majority of stars exist in binary or even multiple star system, gravitationally bound to one another, orbiting a common center of mass. These stellar dance partners can have profound effect on each other's life. A smaller companion star could influence Betelgeuse in several ways. It could have at some point siphoned off material, changing Betelgeuse's mass and influencing its evolutionary path. Or its gravitational tug could cause pulsation or oscillation within the Betelgeuse, leading to changes in brightness. A companion could literally stir the pot. But finding a companion around a star as enormous and bright as Betelgeuse is incredibly difficult. Imagine trying to spot a firefly fluttering next to a blazing bonfire. The supergiant's immense glare, simply washes out anything nearby. It's like trying to find a whisper in the middle of the rock concert. Interestingly, the idea of Betelgeuse companion isn't entirely new. Some astronomers had theorized aforementioned strange variability, but the theory is just a theory without hard evidence, and getting that evidence required revolutionary new techniques. Enter the heroes of our story, the astronomers wielding some of the most powerful telescopes and innovative observational techniques on Earth. Specifically, we are talking about the Gemini North telescope atop the Mauna Kea in Hawaii, and specialized instrument called Alopec, and Hawaiian word for a fox, fitting for its cunning ability to ferret out secrets. The key breakthrough came with a technique called the speckle imaging. Our atmosphere is a turbulent beast. Even the most powerful telescope on Earth still have their view blurred by pockets of air with different temperatures and densities. This makes star twinkle and blur fine details. Speckle imagine works by taking thousands of extremely short exposure images faster than atmosphere can distort their light. Imagine taking a video of dancing flame. Each flame is blurry, but if you take 1,000 snapshot, each one freezes the flame for a tiny fraction of a second. By combining and analyzing these thousands of instantaneous snapshots, sophisticated computer algorithms can reconstruct a much sharper image, effectively cutting through the atmospheric blur. This allowed astronomers to achieve astonishing resolution, almost as if the telescope were in space. They weren't just seeing Betelgeuse as a point of light anymore. They were actually seeing its enormous bulging surface and, crucially, the space immediately surrounding it in unprecedented detail. And there it was, not a point of light, but a distinct smaller object nestled surprisingly close to the colossal red supergiant. The painstaking work of the observation, data processing, and analysis had finally paid off. The secret passenger had been exposed. So, who is this mysterious companion? Astronomers have given its potential name Siwarha, a word from native Hawaiian language offering a mythical bird often associated with duality or of a pair. Some have affectionately called it Betelbuddy. Siwarha is no small fry. It's estimated to be a hot young B-type star, about 1.5 times the mass of our sun, and it gives you some perspective. Our sun is G-type star. The B-type stars are much hotter, brighter, and typically much younger than our sun, burning through their fuel at a furious pace. If Siwarha were alone in the sky, it would be a brilliant blue-white jewel. But next to Betelgeuse, it's overshadowed. Hence, the dark passenger is the name given to it. The most astonishing aspect of this discovery is just how close Siwarha orbits Betelgeuse. It's estimated to be less than the distance between Earth and the Sun, an incredibly tight embrace for such a colossal star. This proximity is critical. It means that the two stars are in an intense gravitational relationship, constantly influencing each other. This tight orbit is now believed to be the primary cause of the Betelgeuse's famous 6 year brightness cycle. The gravitational pull of Siwarha can cause internal oscillations or even induce massive convective plumes on Betelgeuse surface as the companion swings past. Imagine a giant ocean being stirred by passing ship. The wave it creates are the changes we see in Betelgeuse light. Furthermore, being so close, Siwarha may even cause a slight tidal distortion in the Betelgeuse, pulling its immense gaseous envelope out of a perfect sphere. This subtle effect combined with orbital mechanics provide a powerful new explanation for Betelgeuse's long-standing enigmatic behavior. This revelation isn't just a fascinating anecdote, it fundamentally reshapes our understanding of the Betelgeuse and, by extension, how we study and model other massive stars. Knowing it's a binary system allows astronomers to refine their calculations of the Betelgeuse mass, age, and ultimately its fate. For its past, the presence of Siwarha suggests that the Betelgeuse might have started its life as a binary system. Stars formation often produce multiple stars from the same cloud of gas and dust. This implies a shared history from their stellar nursery. For its present, it explains the confusing light curves. The great dimming of 2020 might have been one-off event, but the underlying 6-year cycle is now comfortably explained by Siwarha's gravitational influence. This means our model of other variable stars might also need a re-evaluation if they are hiding similar companions. And for its future, this is perhaps the most intriguing aspect. Betelgeuse is destined to explode as a supernova. When it does, what happens to Siwarha? The companion is in such a tight orbit that the supernova explosion could either blast it away at immense speed, potentially sending it hurtling through galaxy as a runaway star, or it could even affect the companion itself if the blast is close enough. Some theories even suggest that in extremely close binary systems where a massive star explodes, the remnant could eventually become a black hole or a neutron star, with the companion continuing to orbit it and potentially creating detectable gravitational waves. While speculative for Betelgeuse given Siwarha's size, it highlights the complex and violent cosmic ballet that a closed binary system can perform. The discovery of Siwarha is not an end of the story, but merely a new exciting chapter. Astronomers are now intensely focused on this binary system. More detailed observations are underway using even more advanced instruments. Telescopes like James Webb Space Telescope, with its infrared capabilities, could provide even more insight, allowing us to study the chemistry and dynamics of the Betelgeuse atmosphere and how it interacts with its companion. We might even detect a sign of mass transfer if Betelgeuse has indeed been fading. Then it must be feeding its smaller companion. Theoretical atmospheric astrophysicists are also hard at work, updating their models of this stellar evolution to incorporate the presence of close companion. How does a companion affect the timing of the supernova? Does it change the type of elements produced? These are all questions that need to be answered. Betelgeuse remains one of the most and the best target for studying massive star evolution, precisely because it is so close to us and so bright. Every new piece of information helps us understand not just the one star, but the process that govern the lives and death of stars across the entire universe. The story of Betelgeuse and its dark passenger is a powerful reminder of the dynamic and surprising nature of our universe. What we once thought was a lone enigmatic star is in fact part of a complex gravitational intertwined dance. It highlights the persistence of scientific inquiry, the ingenuity of human observation, and the continuous unveiling of the cosmic truth. Every time we peer deeper into the cosmos, we uncover layers of complexity that we never anticipated before. Betelgeuse, a star we have gazed upon for millennia, still had a secret to keep, and now its dark messenger has finally been exposed, our understanding of this familiar stranger in the sky will never be the same again. So, friends, what do you think about Betelgeuse's newfound companion? Let me know in the comments below. And if you enjoyed this cosmic revelation, don't forget to like this video, subscribe for more space discoveries, and hit that notification bell so you don't miss out our next journey through the universe. Thanks for joining live. Thanks for watching. See you in the next one.